Conduit. My name is Timothy Tolo. I'm an electrical technologist. I'm Jamaican, and I'm here to show you how to wire electrical circuit, how to understand electrical concepts, and with me, you can do it. Welcome to You Can Do It, and today we'll be discussing two-point control circuits, from the design to the construction to the operation and the applications. Here we have a schematic diagram of a two-point control circuit. This was set up using multisim. We're going to start from scratch and show you guys how to set it up in multisim. All right, so step one, we go into basics. We take out a single pole double throw switch, two single pole double throw switches. We take them, we flip one horizontally. Then we go for a source. We go for a ground. Go for a ground. We also go for our AC power. We go for our indicator. All right, so we take out our bulb, our source. All right, so we're going to make some adjustments. We adjust to 50 hertz, and we assume that the voltage supply of the system is 110 volts for single phase. Right. Take our light. Take our lines. Black for neutral. If the components are metal, we have to make sure we earth the system. We're going to use blue for the travelers, and we're going to prefer the name for the system, T2, Traveler 2. T1 for the top one. So a return. We apply to the system. All right, so the circuit is already designed. So now we're gonna design it on a workboard. Alright, so here we have our physical layout of our 2-point control of one lamp. So first we're going to connect our earth conductors to all metal components. We're going to ensure that our neutral is connected to the base of the broad base receptacle, and to ensure that it is tightened firmly, and it is then sent back to the source. Next, we're going to connect our traveling conductors to our single pole double throw switch, and we're going to connect those to terminals 1 and 2, which are the travelers 1 and 2. We're connected to both switch A and switch B. Next, we're going to connect our live and return. I'll connect our live conductor to the common and back to the source, and we connect our return from the lamp, the tongue of the broad base receptacle, back to the common of the single pole double throw switch. Alright, so after we finished connecting our circuit, we're going to do some dead circuit tests. Our first dead circuit test is our earth continuity test. So we're going to test if all metal components are earthed. We simply do this by connecting one of the lead to the earth conductor and touch all metal components. You want to make sure that all metal components are earthed. Once you hear the beep, that means that all metal components are earthed. We also want to make sure that our octagonal box is properly earthed. Next, let's go again for those of you who didn't see the earth continuity test. Let us test it again. We touch all metal components. Ensure that there's a beep. Once there is a beep, that means the metal is completely earthed. Alright, after our earth test, we have our polarity test. Our polarity test, we simply test for short circuit. So what we do, we take our neutral conductor and test on the base of the broad base receptacle, right? We also touch all other components in the circuit to see if there is any short circuit or the neutral is connected where it shouldn't be connected. Once that doesn't occur, we then know that the neutral polarity is correct. So let us test again. We touch the base of the broad base. We're supposed to get a beep, right? Then we simply do the live conductor. We test all metal components to ensure that there is no short circuit. Alright. We test the tongue. We got on beep. We switch again. No beep. Then we test our common of the single pole switch. We also test our travelers to ensure that it is connected correctly. Alright, no noise on that side. So if we toggle the switch, however, there will be a connection and there will be continuity in the conductors. So let us do it again. Alright. So let's just switch again. Alright, so our next test is our ring continuity test. Ring continuity test, is what we do. We close the live and neutral conductor from the source, and we create a loop for current to flow. Alright, there's no beep because the circuit is off, so we simple toggle the switch. Once we toggle the switch, we should get a beep as long as the conductors are touching the tongue and the base of the broad base receptacle, then we should get a beep. Alright, and that's the end of our test. Alright, so our last theoretic test is our insulation resistance test. So we want to make sure that we turn our dial on the insulation resistance test to at least twice the amount of voltage the circuit would normally work on. So our first insulation resistance test that we're going to be doing is between conductors as a whole and earth. According to the JS21, for between conductors and a whole, the test shall be made between the conductors as a whole and earth, provided that such tests will be deemed satisfactory if the insulation resistance is not less than 1 megohm. So let us turn our dial. We press test. Once we press test, we will await the reading. Alright, so see, hold on to test. Alright, so we got a reading of 293 mega ohms. So that's not less than 1 mega ohm. So therefore the test is deemed sufficient. Then our next insulation resistance test is between conductors. So according to the JS21, where practicable, a test between conductors shall be carried out. Such shall be deemed to be satisfactory if the insulation resistance is not less than 2 mega ohms. Alright, so what we're going to do, we're going to press test. We're going to look and see if, so we got 4,000 mega ohms, so therefore that is deemed satisfactory. When conducting an insulation resistance test, you want to make sure that your switches is on and make sure that all the conductors are not in place. Alright, so we have our circuit set up from the schematic diagram. So we're going to talk about the operation. In order for the 2-point control of one lamp circuit to work, there has to be a complete path for current to flow. So let us trace the system path using multisim. All right, so the live conductor, it traveled from the source to the common of switch A. Switch A is a single pole double throw switch, right? And then we have traveler 1 and traveler 2 is connected to the traveler conductors, which then is connected back to the traveler 1 and traveler 2 of switch B, which is also a single pole double throw switch. The common terminal of switch B is connected to the return, and the return is connected to the base of the broad base receptacle, right? So, and then we have our broad base receptacle, and when we input the filament, when we input the incandescent bulb, the filament of the incandescent bulb is connected to the tongue of the broad base receptacle. And from the tongue of the broad base receptacle, the filament is also connected to the base of the broad base receptacle, right? So this then is connected to the neutral. The neutral of the broad-based receptacle is connected back to the source. This creates a path, right, for current to flow. But however, for us to better look at the path, there has to be a connection between traveler 1 and the common of switch A or switch B, right? So if we toggle switch A, we see the bulb is energized because there's a path between the common of switch A and traveler 1 and the common of switch B and traveler 1. And this goes back to the return through the bulb and through the neutral and back to the source, right? So if we simple alternate switch B, this opens the path for current to flow. In order, switch B is now on traveler 2. In order for us to energize back the circuit, we would then toggle switch A, which then creates a path for current to flow because there's a straight connection from the live to the common of switch B to traveler 2 of switch B. And this goes back through the return through the bulb and then through the neutral and back to the source, which energizes the circuit. So simple de-energize the circuit, we would then toggle switch B. If we're using metal components, we would then hurt the system. We would then hurt the system. Right? If we hurt the system, right, then we press switch A. See, the circuit works. So if there's an excessive amount of current, it would then travel through the earth conductor to ground. All right, so now we can go back to our workboard and look at the circuit in a practical and a live sense. connected the power to the circuit, we will now test to see if the bulbs are have continuity in them, if the filament is good. If you get a beep when you touch the base and the tongue of the bulb, then that means it's good. Alright, so the bulbs are good. We'll now connect the bulbs. Connect one bulb to the circuit. Ensure that everything is free and they're safe. Then we will now energize the circuit. Once we have energized the circuit, we will now toggle the switch as shown in the operation to ensure that the bulb lights. The bulb glows. Let's go. Alright. Let the bulb glow. We'll now toggle switch B, which will alternate the path for current to flow, opening the circuit, and we'll toggle the switch A to re-energize the circuit, which closes the path for current to flow. Toggle again, see? Toggle one. So application of a 2-point control circuit is it can be used in all ways. And now, after we've done this, we will de-energize. We will circuit. Maritolo. Thank you for watching the video. Remember to like, share, and subscribe. You can find me on Instagram at u.conduit.